Earth science time.
Oh, that was so
Talking about.
Oh man, can't wait to be here. He really wants to do this video, guys.
Talking about Natalie. Talking about surface water. So please write that down. So obviously this is an easy question, but where would we find surface water? What
On the
surface of what? On the surface of Earth, right? As opposed to what other thing that we sometimes will talk about?
Underground water.
Okay, yeah, what we just call groundwater, but yeah, underground water. So the first thing we're going to talk about is this. I'm going to do it in blue. First, I'm going to check to see if you can actually see the blue on the video. Blue. Yeah, it's fine. It's not as good as the black, but it is.
Do you have it quickly zoomed in?
Yeah, it is zoomed in. Write this down.
Did you start your video?
Yeah, I think. Water cycle. You remember? This is the very first year I think I've ever said that someone hasn't sung the water cycle song from.
Water cycle song?
You don't even know it. But good. There was a child here in the past that would constantly sing this song, and it was annoying to me. So that's good. There is a song, but it's stupid. So we're gonna just talk about it with our words instead. Water cycle. So you know about the water cycle. What's the idea behind the water cycle?
It goes up into the sky, and then it comes down from the sky into the water.
Okay, so Levi said it correctly. I heard him, and maybe you didn't, but it doesn't matter because I'm going to repeat what he said. So water, he says simplistically, the water goes up into the sky and then it comes down from the sky, and it does that over and over again, right? The fundamental idea of the water cycle is that Earth's amount of water, like the total amount of water on Earth, is relatively constant. Meaning that it doesn't change over time. In fact, it does change slightly. Earth's a big place with a lot of water. Every year there's probably hundreds to hundreds of thousands of kilograms of water deposited on Earth by asteroid impacts or meteor impacts, or just like even if an asteroid has a large water content, even if it burns up in the atmosphere, that's still part of Earth and it becomes part of Earth's water. So the amount of water on Earth is ever increasing, but only slightly, especially compared to how much, which is a huge amount of water on Earth. I'm sure it's much less than even like 0.1% of Earth's water is added each year. So anyway, so it's relatively constant. The water there's no new water coming to Earth, or at least not on any large scale, and water doesn't leave Earth, at least not on any large scale. So instead, what water does is we usually draw the water cycle like this. There's a little puddle or lake or something, and the water does this. What's this process that I've just shown?
Evaporation.
Good, evaporation. What does it do up here? Condensation. Precipitation, right? These are the precipitation. These are the like fundamental and easy little words about the water cycle. When it's here, we call it surface water, right? When it's in a puddle or a stream or a lake or the ocean, we call it surface water. Evaporation is when it changes, just to make sure we have it all on the same page. Evaporation is when that liquid water turns into what?
Yes.
Yeah, gaseous water vapor. What does gaseous water vapor look like? Someone's going to say it wrong, and I'm going to be glad that they did.
H2O.
It is H2O, but what is gaseous water vapor? Like water vapor in the gas stage. What do we see? Yeah, okay, thank you, Owen. That's wrong. But yeah, no, I wanted someone to say that. But this clouds, you can't see water vapor. Gaseous water vapor, that is just water vapor. Water in the gaseous form is completely invisible. When you see a cloud, that's why I wrote condensation in the cloud here, because condensation is when it changes from what to what?
Water to a gas.
No, try again.
From a vapor to a liquid.
Yeah, from a vapor or a gas to a liquid. So when you see a cloud, it's always one of two things. It's either water droplets just hanging in the sky, millions of tons of water just hanging in the sky, or it's water ice, like little crystals of ice hanging in the sky. You can't see water vapor. When you see a cloud, that's either liquid or solid water. And then you're thinking to yourself, when I said that there's a million tons of water just hanging in the sky, you think, why doesn't it?
Fall.
It does. It's called precipitation. So the precipitation is just what so this is liquid water to gaseous water. This is gaseous water to liquid water, which forms the cloud. And then this is when that liquid or solid water falls from the sky. Okay? That's the water cycle. Do you have questions about the water cycle? Okay, what is it?
When the water goes up.
No. What was your question?
I didn't have a question.
Oh, I thought you
I
said
have
yes.
a question.
Yes.
What holds the clouds in place? is
Okay, good.
gravity affects liquids.
No, you're right. He's exactly right. So if you think back to the forces acting on an object, if we have a cloud, think about just a little cloud, what force is acting on it downward? Gravity. What force might be acting on it upward?
Air.
Yeah. There is these things, and we'll talk about this in a couple chapters, but this is basically the force of air resistance, and there are like thermal air currents, right? Air is always moving up from Earth's surface, and it kind of up bears the clouds. It doesn't do that forever, and if you look at a cloud, it will change while you're looking at it, because this is not a stable situation. Generally, this is much, much less a weaker force than this, and so eventually the water will fall, which is precipitation.
So why
Good
doesn't
question.
it just go like?
Why doesn't it just drop out like if someone emptied a bucket onto the planet
Yeah.
Earth? Basically because the droplets are pretty widely dispersed, right?
So
They're not
can I
all
catch up?
in a lump. Just give me a second. They're not all in a lump, and they're being kind of held up by air currents most of the
It
time.
has to be thick enough that you can like see it.
Have you been through a cloud in an airplane or something? You can see it, but it's more like a mist, right? I don't, but if I had, well, I do. If I have this, right, it hangs in the air. You can't see it on the video. There's no way.
Oh, I can see it here. Oh.
But it hangs in the air for a second, right? As opposed to if I had that same amount of water in a drop, right? But since it's a mist or a fog, like someone over here said, it hangs there for a second, right? Does that make sense? Yeah, but it's
just
bigger
looks like water.
and higher up, and so it kind of just.
Have you ever driven through fog? It's basically what it
There you
is,
go.
and it
Yeah.
looks a little bit bright.
Yeah,
There you go, that's what it
it's a cloud.
I mean, yeah. My only question is like, why didn't it just go?
Good. That is a good question. I'm glad you asked that. Let's move on to this. So we're going to focus right now on this step. Ooh, I got a really slippery floor now. We're going to focus on this step. Can you tell what I'm trying to draw here?
Precipitation.
Precipitation. Precipitation. Okay, and we're gonna mostly focus on this little bit here. Can you tell what this is supposed to be?
Ground.
Good. Ground. When this precipitation falls on this ground, there are three things that can happen. You're going to talk about this. This class is all about lists of three things, and this list of three things is what do you think can happen when?
Erosion.
Okay, can make a puddle or.
Okay, hold on. Let's do them one at a time, because we're going to write a little bit about them. So what's one thing that can happen when this water is on the ground?
Erosion.
Yes, but we're going to get to that in a second. Okay,
Puddle up.
okay. So
Like on the blacktop, there's like
We're
a
gonna-
bunch of puddles.
and then eventually that puddle will do something. I'm talking about when the water moves, it will do what? Okay, so one thing is it can evaporate. Evaporation. And we're not going to talk about that because we know what evaporation is. What's another thing it could do? Okay, that's exactly right. That's called infiltration. And so we are going to define that. Infiltration is where the water moves.
Soaks in.
Yeah, water moves. Soaks in is right, but the water moves into what? The soils. It goes inside of the soil particles.
Pores.
Yeah, into the pores. Water moves into the pores. Yep, hold on a second. Yes, but the water moves into the pores between sediments. And that's called infiltration. So infiltration is where the easy way to describe it is it soaks in, but it basically fills the pore spaces. What else soaks stuff up? A sponge or a towel. And both of those things, what's happening is the water is going into the pore spaces. That's why a sponge looks the way it does. That's why it's absorbent and yellow and porous, right? Is because it can hold the water in its little pore spaces. Same thing happens here. And then the third thing Tylee is itching to tell us is when it does what?
It goes into a
Right. And we call this runoff. When it moves to somewhere else, that's called runoff. And usually this is because it's on a what? Yeah, slope, generally. Runoff. The water, we'll just put moves elsewhere. Okay, and so when we're talking about just water moving, that's not really super important to us. But what else happens when this occurs, do you think? What else is moving with it sometimes?
Erosion. Sediment.
Sediment's moving with it, which we call erosion. So because of this, there is erosion. And we're going to talk about
Water moves everywhere.
elsewhere is what I put. Just somewhere else. You ever heard the word elsewhere? This one we'll talk about in the next chapter. This one we'll come back to in chapter 10. This one we're going to talk about today. And then evaporation, you should be aware of evaporation already. Knock it off, please. Okay, so there are some things that affect runoff. So we're going to, hope you have these two. We're going to talk about the factors that affect runoff. We already said one of them. Let me switch back to black. Factors affecting runoff? What's one thing that affects whether the water runs off? Yeah, the slope. So obviously, and steeper slopes would generate more runoff. On a steep slope, less of the water will infiltrate or evaporate, and more of it will run off.
So the slope angle.
Yeah, that's slope. What else?
Red Mountain.
Okay, so yes, technically, Owen, on different planets with different amounts of gravity, this would change. But since we're talking about Earth science and Earth's gravity is the same everywhere, you're right, but that's not something we usually consider. So gravity is technically true.
Location, because obviously if it's like on soil, it's going to go.
Okay, so you're not really talking about location, you're talking about the type of sediment, which is true. Type of sediment.
Would it be how fast the precipitation's coming down?
Okay, yep. Amount. We'll put amount of precipitation because you're right. You'll notice, like, if there's a very gentle spring rain or something, very little of it probably is going to run off. Amount of precipitation. I'm going to abbreviate that. There's probably very little runoff. But if there's a really strong thunderstorm that lasts for an hour in the summertime, you'll probably see a lot of runoff because there's just more water. Basically, when the pore spaces get full, right, then all of it becomes runoff. What else do you think? There's one other primary one I can think of. What's going to have...
Just a hint.
Yeah, I was about to. What's going to have more precipitation if you have a nice grassy hill outside of town or a pile of dirt outside of town?
The grassy hill.
The grassy hill is going to have more runoff?
No, it's
No,
not.
Less. So what affects it? What we could say in general.
If there's less vegetation.
Yeah, we're just going to put vegetation. Vegetation affects it as well. In fact, a lot of people will plant grass on a hill even if they don't really need grass to look pretty or to feed their cattle or whatever, just so that runoff doesn't occur and wash the hill away. So greater slope means greater runoff. More pore spaces means less runoff. Do you see why that would be? Because more of it will infiltrate. More precipitation means more runoff, and less vegetation means more runoff. So basically, slope and amount of precipitation are directly proportional to runoff, and type of sediment, pore spaces and vegetation are inversely proportional to to runoff. Okay, questions on runoff? Good. Let's talk now about this. You have this as a vocab word, but here are what we're going to talk about next. Watershed. We'll say watersheds. Watersheds. In Britain, or in other countries, in what we call Commonwealth countries like Britain and Canada and Australia, this word we use the word catchment instead, but a watershed, and you should kind of, I don't know, I wouldn't say memorize, but you need to have in your head that this word is an area of land, first of all. It's an area of land where any precipitation that falls in that area will eventually end up in a certain body of water. Area of land where if precipitation falls, it will end up in a certain, I'm going to put given, body of water. So every body of water has a watershed. It has an area around it that anything that falls there will wind up in that body of water. So here we have the White River, right? The White River, I'm going to draw this. Can you tell what I tried to draw? I tried to draw Nebraska. I'm going to do...
Does not look like Nebraska.
You know what? I did my best.
Looks like a plant.
Okay, well, just be nice for once. So here's the White River. So we're talking about its watershed, which is the area of land where any drop of water that falls will end up in that. Do you think if a drop of water falls here, it will end up in the White River first? No. So probably the area of the White River watershed is more like this, right? Do you know what river the White River flows into?
Niobrara.
The Niobrara, which is up here more. So the Niobrara actually gets much thicker than that. But so the Niobrara River here running along the top of Nebraska, is that going to have a larger or smaller watershed than the White River? Larger, because it's a larger river. And here's the main thing I want to talk to you about. Can these watersheds overlap? I just drew it as if they can. But yeah, they can. Water that ends up in the White River, because the White River goes into the Niobrara River, water that lands here will eventually end up in the Niobrara as well. And then all of this is the watershed of what other river?
Missouri.
The Missouri River. I'm glad you know about your rivers, because that makes it a lot easier for me. The Missouri River's watershed is like that, and then this eventually goes into the
Gulf of Mexico,
but before that,
Mississippi.
the Mississippi, which has a watershed all the way not blue, a watershed all the way to the Rocky Mountains, right? And then the Gulf of Mexico which has an even larger watershed. Look at me at page 227. They have a much more professional drawing of this, what's called the drainage basin of the Mississippi River, which I would also call the watershed. So the Mississippi River's watershed is this whole enormous area of land, and there are other smaller watersheds contained within it. Every body of water, a puddle in your driveway has its own watershed, a certain small area of land around it where it'll end up in that puddle. And then that watershed spills into another, and that watershed spills into another, and all of them eventually get to the
Ocean.
Ocean. Each ocean has its own watershed as well. You should also write down that sometimes there are like hills or I need black. Sometimes there are raised land features. Raised land features. Oops, spell it right. Features separating watersheds are called divides. Are called divides. Have you ever heard of a divide?
Yeah,
Yep.
What one specifically have you heard of?
the
Grand
Rocky
Canyon.
Mountains.
In the Rocky Mountains, there's something called the Continental Divide, and what that does is it separates the whole big watershed on the eastern side of the United States for the Mississippi from the Colorado River watershed and other river watersheds on the western United States. Basically, the Rocky Mountains are a divide where if a drop of water spills on the east half, it'll all end up in the Atlantic Ocean, and if it spills on the left half, it'll all end up in the Pacific Ocean. We will talk more about the rest of this another time. For now, it's you have questions about watersheds? I should have asked. Do you?